Hello, welcome. How you doing? How's it going? Thanks for watching. Thanks for tuning in. I hope life's good. Um, let's take a look at 7.3. Uh, Again, thanks for watching. Tell your friends to watch. Tell them, hey, Mr. Skis, he loves when you watch the videos. Just do him a favor. So tell your friends to watch the videos. 7.3 is interior and exterior angles, and I'd like to do the shortest of recaps of 7.2 just to remind you and get those juices flowing. The two types of angles that we saw in 7.2 were central angles and inscribed angles. Okay, there was central and inscribed. What was the main thing that we were looking for? If the vertex was at the center, we said that it was central. If the vertex was on the edge, we said that it was inscribed. The vertex is the one characteristic that we were really focusing on. If it was at the center, we called it central. If it was on the edge, we called it inscribed. So I want you to remember that. I want us to keep in that rhythm that where the vertex is located is such an important detail. So let's create a new type of angle, one that isn't inscribed and one that isn't central. Okay? So let's draw two chords, AB and let's draw CD. And they're going to intersect, okay? So these two chords are intersecting. We've created a couple of angles here, would you agree, right? We have this angle and this angle. What type of angle are those? Those are vertical angles because they're made by intersecting lines. And we have these two angles, right? Those are vertical angles. But because we're inside of a circle, we have an even better name for them. So let's continue on. The intersection is point E. All right. What is the relationship between A, E, C? I forgot to label the letters, so let's label A, B, and C, D. What is the relationship between A, E, C and D, E, B? Well, that's what I just said. They are vertical angles. AKA, they're equal. Right? Vertical angles are the same size. What is the intercepted arc of AEC? AEC, the intercepted arc is AC. All right. Actually, let me use blue so that way it matches. Right? So we got the blue angle and we have the blue arc. And what is the intercepted arc of DEB? We got the blue angle, we got the blue arc. DB. Those are indeed minor arcs, so we're only using two letters, right? So in conclusion, what can we say about AEC? AEC is equal to the sum of those two arcs added together and then take half of it. So you add the arcs and you divide by 2 or multiply by a half, that's the same thing, and you find the measure of the angle, okay? So let's run through a few examples so you can see how that works. So, which by the way, we didn't even state what this is. Let's state what this is. We just created interior angles. Why is this an interior angle? Because the vertex is in the interior of the circle, right? What it's not at the center, okay? This is not a central angle. I can't stress that enough, right? The vertex is just somewhere inside, but it's not specifically at point P, right? P is the center. So if I were to draw an angle like that, that's a central angle. But this point, when we draw this angle, it's just somewhere in the inside. We call it an interior angle, okay? Because it's, well, inside of the angle. So the measure of an interior angle in a circle is half the sum of its intercepted arcs. So you add the arcs, arc plus arc, divided by 2. Okay, that's kind of a nice, simple way to put it. All right, so if we're trying to find angle X, okay, this arc and this arc are created, right? There's the way I think of it, right? There's the arc in front of it, and there's the arc behind it. Okay, there's the arc in front of it, and there's the arc behind it. We're ignoring these two, right? Scribble those out. There's the arc in front, and there's the arc behind. So the sum of the arcs, so the angle is equal to the sum of the arcs divided by 2. It's that straightforward, okay? The sum of the arcs divided by 2. And what do we end up with here? Let me plug this into my calculator real quick. 91 plus 55 is 146. Divided by 2 is 73 degrees. Let's look at example B. We know the angle, and we're missing an arc. So let's think about that. The measure of the angle is equal to the sum of the arcs divided by 2. It's just that this time we're missing an arc, right? Here's the arc in front, and here's the arc behind. The angle is equal to the 2 arcs added together and divided by 2, and solve. So how do we solve for x here? Well, if we're dividing by 2 and we want to get rid of that, we're going to multiply by 2 to each side to go ahead and cancel that out. So that's 64. And now if we're adding 35, we're going to subtract 35 to cancel that out. And 64 minus 35, 64 minus 35 is 29. So the measure of the arc is 29. So we wrote the same equation, it's just that we were missing something different. Instead of missing the angle, we were missing the arc. But nonetheless, one more time, the interior angle, because the vertex is in the inside, is equal to the 2 arcs added together divided by 2. Your equation will always look something like this for interior angles, right? Don't forget that there are central angles and there are inscribed angles, okay? They will be mixed up on occasion. You got to be able to differentiate between the 3. Central, the vertex is at the center. Inscribed, the vertex is on the edge. And interior, the vertex is just somewhere in the middle, right? Inside the circle, but not at the center. I'm going to get you started on this problem, and then I'm going to ask a question on this one, okay? I'm going to ask a question on this one. Look at what angle we're trying to find. We're trying to find this angle here, which has nothing to do with these 2 arcs. It has nothing to do with those 2 arcs, right? It has to deal with these 2 arcs. So in this problem, whoops, I didn't mean to completely erase my highlight there. In this problem, we kind of need to solve for this angle first, and then we can solve for x. So why don't you guys solve for angle y for me? Here's angle y, and here are the arcs. Go ahead and solve for angle y for me. Answers popping up on screen. Okay, so in this situation, right, if this is the angle, here's the arc in front of it, here's the arc behind it, the angle is equal to the 2 arcs added together divided by 2. That's all you needed to do for me, and you should have chose 106 plus 86 divided by 2 is 96. So angle y that we sort of made up is 96 degrees. Now, how is that relevant to angle x? Well, guess what? Here's some throwback knowledge, as always, right? We always have some throwback previous class stuff. This is a line, and these two angles create that line. What do we call that? A linear pair. And we know that linear pairs add to 180. So what does that mean angle X has to be? Well, 180 minus 96 is 84. X has to be 84 degrees because 84 and 96 create 180. So there was kind of an in-between step, right? You got to be able to catch that. I hope you let me clarify why we had to solve for this first, because these arcs are not in front or behind angle X as I've been referring to them, right? These arcs are relevant to find these angles, yeah? You could have solved for these arcs as well. That is theoretically possible, but I feel like, just finding this and then doing a linear pair seems a little more straightforward. But there are other ways to potentially go about that. I'm not saying you would be wrong. That's just the way I chose in this moment. Let's just have you jump right into this one. These are indeed the arcs that are relevant for 65, right? In front and behind. So just go ahead and solve for that missing arc for me, arc X. So a few answers pop on screen. So in this situation, the interior angle, right, 65 degrees, is equal to the two arcs added together divided by 2. Exact same problem as B, right? So times 2 times 2, we get 130. These cancel out. If we're adding 36, we subtract 36, and we get 94. X equals 94. So there's that. And there's our examples for interior angles. Let's bust through this problem here. What minute mark are we at? We're at 12. Okay, this video might be a little longer, and I apologize. But it is important that we do this example. So let's fill in what we already know. This is 75 degrees, and arc BC is 100 degrees, and arc CD is 60 degrees, and GD is a tangent line. All right, beautiful. So what can we do here? What can we solve for? When you see solve for the measure of angle 2, I would not focus on that first. I've discussed this before, that you don't have to solve this problem in order of how the answers here are given. I would solve for the things that you know how to do, right? So let's just observe for 20 seconds here what type of angles we have. We have inscribed angles because the vertex is on the edge. The vertex is on the edge. The vertex is on the edge, right? We have all kinds of inscribed angles. There are no central angles, right? None of these are central because the center is not the vertex for anything. So what do you recall about inscribed angles? Inscribed is equal to half the arc. So if I know that this arc is 60, well then the inscribed angle has to be 30. Okay, so there's that one, right? I didn't solve for 2 first. I solved for 3. Do I know the measure of this arc? Not at the moment, I don't, but maybe I'll get there eventually. But no, not at the moment. I don't know the measure of this arc. So let's keep rolling here. Well, this arc is created by this angle as well. So if this is 60, this is 30. I hope you're seeing that connection there. Okay. And this is 100, and angle 5 connects to that. So if this is 100, then this is 50. You see how I'm just knocking out these easy ones first? I'm just dividing by 2, right? That's pretty straightforward. What else can I solve for? You might not see this as quickly as I did, but all of a sudden I see a triangle, and I know that there's 180 degrees in a triangle. 75 and 50 add to 125, subtract that from 180, and the third remaining angle is 55. So angle 2 is 55. So I actually solve for that fourth. Okay, what else can we do? What else are we even looking for? Where's angle 4? Oh, angle 4 is over here. Now, it's sort of tricky here. This is definitely tricky, but this is an inscribed angle because the vertex is on the edge and it intersects this arc. This is probably the trickiest inscribed angle you'll see. This inscribed angle, because the vertex is on the edge, creates this arc, just like this inscribed angle creates this arc, and this inscribed angle creates the same 60-degree arc. Well, so does this one, okay? So that means angle 4 is also 30. And now we're solving for the rest of the arcs. So keep in mind that there's 180 degrees all the way around, right? Keep that in mind. We're trying to solve for AB. I don't see anything obvious at the moment, so we'll chill there. B to D, well, that's pretty straightforward. That's just a combination of BC and CD. So that's just 160. And then DA, D to A. Okay, well, I know this inscribed angle. Would you look at that? I'm going the other direction, right? Observe everything, right? When I said OAB, do I know anything? Well, I realized that, well, I don't even know this angle here, right? I don't know this angle, and this angle produces this arc, but I'm clueless about both, so I don't have much to go off of. But I know, I see this arc, and I know this angle is 55, so double it, 110, and you get the measure of the arc, right? I'm going the other way around, right? Instead of taking half the arc and getting the angle, I'm doubling the angle and getting the arc. And now I can solve for AB because I know that this needs to be 360 degrees all the way around. So let me add together what we already have, 100, 60, and 110. That gives me 270. So what's left is 90 to get me all the way to 360, right? So that's 90. Whoops. So that's 90. Are there other ways to find some of those guys? 100%. There is. There are a couple ways, right? You could have observed the triangles a little bit more, right? Maybe I ignored some triangle situations. You could have found some linear pairs, potentially, right? And there are some ways to kind of, in a roundabout way, find some of these. So there is no like 100% one way to do it. All right. So, yeah, I'm sorry. This one's going to be a little longer, but that's okay. I hope that's, we got our day off. Hopefully you're watching this on Wednesday, and, it's just something to do. So draw two distinct rays with endpoint P and that intersect circle O. So here's a straight line for our ray, and here's a straight line for our ray. Beautiful. And it intersects O here, 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 and here. Label the intersections A, B, C, and D. What did you draw? We drew an exterior angle. Did I skip that question in the top? No. We drew an exterior angle. Okay, so how is this an exterior angle? How is this angle right here exterior? Because the vertex is on the outside. So we have four different types of angles that we've seen. Central, the vertex is at the center. Inscribed, the vertex is on the edge. Interior, we just saw, the vertex is just somewhere in the middle. And then exterior, the vertex is on the outside. Also, something funny that I just noticed is that we didn't use interior angles once in this example, right? Sometimes that may be the case. I know this lesson is focused on interior and exterior, but could I have done that? Yes. If I know this angle and I know this arc, I could have solved for that arc. But the fact of the matter is that I almost find it easier to use the fact that it adds up to 360, right? There is no one way to do this, okay? And I hope you find joy in that as opposed to stress. I hope you're like, man, you know, there are several options. So look for them. Name the two arcs that are in the interior of the angle, B to D and A to C. B to D and A to C, all right? Which appears to be larger, B to D, and which appears to be smaller, A to C. The conclusion is, to find the measure of angle P here, we do big arc minus small arc divided by 2. We do big arc minus small arc divided by 2. Okay, let's try to keep this like at 22.5 minutes or something and jump straight into an example. So to find the exterior angle, we take big arc minus small arc and divide it by 2. Okay, so do we know the big arc here? Do we know the big arc? Yes, it's 111. Do we know the small arc? No. Can we find the small arc? Yes, because we know this adds to 360 degrees. So 111 plus 104 plus 104 again. Okay, interesting. And then subtract that from 360. Okay, the small one is 41 degrees. So the measure of the angle is big arc minus small arc divided by 2. And then you get 35 degrees. So notice the similarity to the above. Before we were adding the arcs together, now we're subtracting the arcs. Okay? Now we're subtracting the arcs. Let's have one last question. I'll give you the setup and you just solve. Here's C. The setup here is the exterior angle is equal to the big arc minus the small arc divided by 2. So now we're trying to solve for the arc. Similar to these problems right here, B and D. Maybe you look back up in your notes to see that, okay? Take a look at how, I had to get rid of the 2 and whatnot. Before the question pops up on screen, I'm going to continue on. I'm going to continue on to solve the rest of these, but if you feel I don't want to force you to watch the whole thing. If you feel like you've learned enough, that's great, but if you'd like to see a few more exterior angle problems, I encourage you to stick around, okay? So I'll respect your time. However, I'm going to keep going, okay? So last question popping up on screen, solve for x. All right, so what did you do? Times 2 times 2. 38 times 2 is 76. Cancels out the 2. 180 minus x. When you subtract the 180 away, be careful about the negatives here. When you subtract the 180, we're going to get negative 104 equals negative x. But you just divide by negative 1 to cancel out the negatives, and you get 104 degrees for the measure of the small arc. All right, so I'm going to keep going. What are we at? We're at 24 minutes. So, I mean, it is what it is. That was the last question. So this one's interesting. These rays are tangent. These rays are tangent to the circle. So if this is 138, well, this arc is the rest of the circle. So what's 360 minus 108? Or 138, sorry. 222. So there's only 2 arcs here, and they have to add to 360, of course. So big arc is 222, small arc is 138, divided by 2. So 222 minus 138, divided by 2 is 42 degrees. Okay. Big arc minus small arc equals angle. What's going on here? This isn't even an exterior angle. We're just throwing in something random. This vertex is on the edge of the circle. This is actually an inscribed. So I don't know if this is just a mistake that I accidentally put in the wrong picture, or if I was like, you know what, let's try to be clever. Either way, we're going to pretend that we're trying to be clever. Yeah, it's inscribed. So how can we find the measure of this arc? Well, if I know this angle, I can double it to find this arc. And then if I know that arc, I know the other one has to add to 360. Okay? So double 96, and I get 192. And if that's 192, like I just said, it has to add to 360. So 360 minus 192 is 168. Oops, 168. All right, two more. Find the value of x and y. Find the value of x and y. Again, this is exterior because the vertex is on the outside. And we don't know the angle and we don't know this arc. So that's kind of an issue. But can we solve for this arc? Yes. 1 arc, 2 arc, 3 arcs. In total, the 3 need to add to 360. So 134 plus 12 is 146. And then 360 minus 146, this is 214. And now that we know the big arc, the exterior angle is equal to the big arc minus the small arc divided by 2. X equals 40. Last but not least, we don't know either arc, and we know the angle, but you know, y minus x, big arc minus small arc divided by 2 equals 50. Right? There's not a lot to go off of. But what else do I know? I know that these arcs add to 360. So we have two equations that are true. This is what I like to call a system of equations. So we could solve for y here. And if y is equal to 360 minus x, well then plug that in to the equation. Instead of writing y, let's write 360 minus x for this guy, and then minus x again because, well, that's still there. If you solve the math on this, 360 minus 2x divided by 2 equals 50. If you divide by 2, you get 180 minus x equals 50. I'm running out of room. I'm sorry. This is a slightly longer question. 50 minus 180 is negative 130. So x equals 130. You see how I did that? I know I did that a little quick, but it's a system of equations. This is something that you saw in Algebra 1. We're using what's called substitution. If we solve for y, we can substitute that in, and then it creates an equation that's solvable. X is 130, making y 230, because it has to add to 360. 230 plus 130 is 360. All right, so I kept that under 30 minutes. I appreciate those who stuck around and wanted to see each example. If you're still here, you're still listening to me, thank you. Thank you for watching. Tell your friends to watch. Tell them that the video is not actually 30 minutes long and that the last question shows up about 22 minutes in. Yeah. Have a good one. I'll see you in class.